Hello, welcome back. Today's story, Docker. What is Docker? Introduction to Docker. Docker is a platform that allows you to create, run, and manage containers. Containers are isolated environments that contain everything you need to run an application, such as the code, the library, and the dependencies. Docker makes it easy to build, ship, and deploy applications over cloud. Some of the benefits of using Docker are: portability. You can write your application once and run it anywhere without worrying about the underlying infrastructure or operating system. Efficiency. You can run multiple containers on the same host, sharing the resources and reducing the overhead of virtual machines. Productivity. You can speed up your development and delivery process using Docker to create, test, and deploy your application in a consistent and reliable way. Docker technologies. Docker technologies are the tools and services that Docker provides to help developers and operators build, run, and manage containerized applications. Some of the Docker technologies are: Docker Engine. This is the core component of Docker that creates and runs containers using the Linux kernel features such as namespaces, groups, and overlays. Docker Engine also expresses a REST API that allows other tools to interact with it. Docker CLI. This is the command line interface that allows users to interact with Docker Engine. It supports various commands to build, run, and manage containers and images. Docker Compose. This is a tool that allows users to define and run multi-container applications using a YAML file. It simplifies the process of creating, scaling, and networking containers. Docker Hub. This is a cloud-based registry service that allows users to store and distribute Docker images. It also provides official images from trusted sources such as Red Hat, IBM, and Microsoft. Docker Desktop. This is a tool that allows users to run Docker on their local machines, either on Windows or Mac. It provides an easy-to-use graphical interface and integrates with other tools such as Kubernetes, Visual Studio Code, and GitHub. Docker Swarm. This is a tool that allows users to orchestrate and manage a cluster of Docker nodes. It provides features such as service discovery, load balancing, and scaling. Installation of Docker. To install Docker, you need to follow the instructions for your operating system or cloud service. You can find the installation guides on the Docker website or on other online sources. Here are some examples of how to install Docker on other platforms. We give you links in the description. What is Dockerfile? A Dockerfile is the text file that contains a series of commands or instructions to create a Docker image. A Docker image is a self-contained program or system that can run on any Linux server. A Dockerfile can use an existing image as a base or create a new one. The commands or instructions are executed in order they are written. The Docker Engine command that triggers the image creation process is Docker build. Some of the common commands or instructions that you can use in a Dockerfile are: from. This specifies the parent image from which you are building. A Dockerfile must begin with a from instruction. Run. This executes a command in a new layer on the top of the current image and commits the results. This is useful for installing packages or running scripts. Copy. These copies files are data directories from the source to the destination in the image's file system. CMD. This specifies the default command to run when the computer container starts. There can only be one CMD instruction in a Docker file. How to create Docker image? To create a Docker image, you need to follow these steps. 1. Write a Docker file that specifies the base image and changes you want to make it. A Docker file is a text file that contains a series of commands or instructions to create a Docker image. These instructions are in fact a group of commands executed automatically in the Docker environment to build a specific Docker image. 2. Build the image using the Docker file. Use the command docker build, tag name, to build the image. The tag option allows you to define the name of your image. You can check the list of images on your machine by running Docker images. 3. Host a Docker image on a registry. A registry is a service that stores and distributes Docker images. You can use Docker Hub, which is the official Docker registry, or other third-party services. To host your image on Docker Hub, you need to create an account and log in with the Docker login. Then you can push your image with Docker push username tag name, where username is your Docker Hub username. 4. Pull and run the image on the target machine. To run your image on other machine, you need to pull it from the registry with Docker pull username tag name. Then you can run the image with Docker run optional username tag name command. This will start a container based on the image and execute the command inside it. Now let's see how to start, stop, and remove a container in Docker hands on Docker. To start and stop and remove a container in Docker, you can use the following commands. To start a container, you can use the command docker start. This will resume a stopper container and attach it to the standard input, output, and error system. To stop a container, you can use the command docker stop. This will send a signal to the container which will allow it to perform any necessary cleanup before exiting. You can also specify a timeout value with the T option, which is 10 seconds by default. To remove a container, you can use the command docker rm. This will delete the container and free up any resources it was using. You can only remove a stopper container unless you use the F option, which will force the removal of a running container by sending a kill signal. However, this is not recommended as it may cause data loss or corruption in the container. You can also use the option rm when you run a container with the command docker rm. This will automatically remove the container when it stops without the need to use the command docker rm. This is useful for short-lived or disposable containers. Some of the challenges that Docker help you solve are: dependency management. You can avoid the problems of incompatible or missing dependencies by packaging them with your application in a container. Environment consistency. You can ensure that your application runs the same way in every environment from development to production by using the same container image. Deployment automation. You can simplify and streamline your deployment process by using Docker commands and tools to build, run, and manage containers. Conclusion. To conclude, Docker is a revolutionary technology that simplifies isolation and provides environment independency. However, it is recommended to use Docker only in the development and testing environments and not in the production applications yet, as it requires a bit more maturity. Despite its downsides, Docker has shown significant benefits in the organizations that use it. Thanks for watching. Hit the like button, subscribe for more videos.